Okay, we're going to talk today about landforms that glaciers create. Glaciers are amazing at what they do and powerful. And so, what I want to do is describe the landscape features that are produced by glacial erosion, name and describe 5 features formed by glacial deposition, and then explain how lakes are formed. And I think glacial lakes are probably one of those cool things that we don't think about, but they're so powerful force in nature, and they're really cool. Their own little ecosystem. So. What I want to do is talk about the first 2 types of glaciers. You either have a valley glacier or you have a continental ice sheet. And so both are moving ice, both are moving snow, but valley glaciers are just what they sound like. They're snow and ice in mountains pushing down. And then you have the continental ice sheet, which is like taking applesauce and putting it on your desk. And eventually, this little mound will flatten out and smooth around. And so it pushes a lot of snow out from the middle. So if we look at, a mountain glacier, a valley glacier, what are they doing? They're going through an area of the valley and they're breaking off a lot of rock. They're destroying, pulverizing, but in the process they make this wall much steeper, and so it makes this deep U look. In the process, some of the material off the bottom of the floor of the valley can pull up. And if it's in a circular shape, it's called a cirque. And it does that. Another form of glacial erosion are artes. And basically, it's these sawtooth ridges. And I think the best way to do is show you what it looks like. And so in this picture, we have this glacier that came through here, and as it did, it pulled up this bowl-shaped depression, right? And clearly, this is a glacial valley because it's in the shape of a U. But as you see, it's chewed off this one side, and so we have these sawtooth ridge and this area that's been cut off by the glacier. That's an, I believe, a rate. So I call them arties, but I believe the pronunciation is a rate. And this is that cirque, that bowl-shaped depression that's pulled up. A horn. Horns are when you have multiple glaciers coming through from different angles, and it cuts off the mountain in a pyramid type shape. So I'll come back to Tarn here in a minute, but this is a horn, right? So glacier came through on one side, glacier came through on another side, glacier came through on a third side, and you have this pyramidal shape. A tarn is a glacial lake. And basically, what happens is, as the glacier is moving forward, all of that material then is pulverized and goes into the water, moves down from its original area. So, if this is that original cirque, you have a waterfall coming in here of melting stream water. This down here pond would be the tarn or the glacial lake. Now, what's really cool is glaciers are really good at, they're like sandpaper, right? So we get all this crap that's in these glacial ice, rocks, bits of debris. And what happens is, as it moves over the top of solid rock, it scratches. And so this is a picture from out at one of the quarries here locally. You can see my pocket knife down here. And so what happened, there was a rock in the bottom of the glacier, and the lines are all moving straight up and down in this picture. There's a couple of side marks. I think that was one they had scraped the limestone down, but up and down, you can see that this is actually moving from this direction to this direction. And what we know is that's the northeast to the southwest, because that was the direction of flow of the glacial ice. Every once in a while, though, we see big rocks that stick out, and basically what has happened is The glaciers have worn them down. Roches montagnes are pretty simple. This is called the plucking face. I didn't make that up, by the way. This is the plucking face. And as the glacier goes from, in this case, to the right to the left, bits and pieces of rock fragment are ended up picked up by the glacier and moved down the line, and it gets this distinct look. You can see them right here. So this would be the direction of flow of the glacier, and then this would be the plucking face. Just remember, I said earlier, glaciers are U-shaped. Rivers are V. So if we look at a glacier, it's easy to see that if you have a V-shaped valley, it's a river glacier. If you have a U-shaped valley, it's a glacier. I'm sorry, I said that wrong. I didn't mean to. If you have a V-shaped valley, it's a river. If you have a U-shaped valley, it's a glacier. I said the word glacier, I didn't mean to. So as it kind of moves, we get more and more ice. And so what ends up happening is it's just like a river. We have small tributary glaciers that feed into bigger glaciers. If we have a glacier that cuts off one other glacier, it creates what's called a hanging valley. And so here's a good picture. A glacier came from the top to the bottom, the top to the bottom, but there was another glacier right here. And so what we call these are tributary glaciers, and what ends up happening is the original glacier, the main channel came through here. And so what came first? This is the last one. This is the area that is the tributary glacier. And so you have hanging valleys. In other words, the valley is hanging. So here is a glacial valley. You can see it's in the shape of a U. Here's a hanging valley. Cut it off. In fact, this one's still melting. Same thing here. Hanging valley, hanging valley, hanging valley. Here's a hanging valley right here. Good example of the U shape, right? U. Very easy to see. Channel erosion. When we're talking about glacial erosion of areas, what happens is it can be destroyed. Continental ice sheets, same thing. This is like a bulldozer, and basically what happens is it is going from higher elevation to lower elevation with glacial pressure. And what does it do? It scratches the surface, it breaks off rock, and in the process, it destroys the landscape. And so again, we go back to my image here, where there's my pocket knife. The direction of the scratch is the direction of the glacier. This is a small little erratic. This is a scratcher, if you will. And you'll notice you see, here's my pocket knife, the scratches are on the bottom of the rock. And so this is a scratcher. And again, northeast to southwest. This is southern, halfway in Illinois. Unsorted. I said earlier, glaciers are like bulldozers. And so when they drop off stuff, it is not sorted. If it's sorted, it's a river. Heaviest to lightest. This case, it just looks like chunks of stuff everywhere. Here's those striations again. This is out at one of the stone quarries. And if you look, we have the direction of flow. And actually, in this case, the direction of the flow is from the top to the bottom. And so, pretty simple. This is called glacial polish. And basically, harder rock pushes the glacier back the other direction. So it's kind of like a river of ice that's rounding and smoothing. Glacial deposition, right? So as ice melts, material deposits. All right, that makes sense. So one of my favorite is an erratic. Anything that's in the ice comes out. So this is an erratic. Clearly this rock was here before the trees. So if you look at this rock was somewhere up in Canada, And what happened is it broke loose, went into the glacier, and the glacier took it like a conveyor belt and dropped it off. Here's a really cool erratic. Here, Star, look. Here's a really cool erratic. So these two erratics came down together from Canada, but what happened was the one, when it settled out of the ice, settled straight down on top, and it just stayed there. Sorry, Star was here, and I just wanted to show her. It was really cool. Thank you, Star. Here's another erratic, and you can see this is my buddy here over on the left. This piece all the way up in, again, Canada, as it came down, it deposited. I think this one, I'm pretty sure, is in the Dakotas. I can't remember where this picture was taken. Glacial pavement, pretty simple. Um, what do we see in glacier here? If you look, what's really cool about this image is these rocks are sitting in the exact same place that the glacier left them, right? You can actually see that this one was pushed. Scratch, 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 it's there, right? And so we know the direction of the push. So we see striations, we see erratics, right? So let's recap real quick. Evidence, erratics, U-shaped valleys, hanging valleys, striations, glaciers, glacial drift, right? So glacial drift's easy. It's anything that's in the glacier and it drops out. So one of those things is called glacial till, right? And glacial till is just rock material being deposited by a glacier. It's all the stuff they scrape off. Stratified drift. Again, if we have stratified drift, it comes from a stream. It comes from a river. So if that's the case, then we have this layering of the rocks. The meltwater, what's really cool about meltwater from glaciers is a lot of times it's called glacial milk. It's pulverized and it looks milky white. A moraine. A moraine is basically the end line of a glacier and all of the material drops out onto the ground. And so there's a couple different types of moraines. We have our lateral moraine, just like in football. If a person running the ball flips the ball off to the side, it's a lateral, right? This is a lateral moraine. And then a medial is in the middle. Now, lateral moraines become medial moraines. I'll show you. So here in this picture, we have a number of glaciers, and we can count them because everywhere where we see these lines, this is debris that's dropping off of the side of the mountain as the glacier is moving. And so rock and crap are picked up. And so this is a medial moraine in the middle, but the medial moraine came from the rock on the side of the mountain. And so that is a lateral moraine turned into a medial moraine. And so every time we see these lines, 1, 2, 3, 4, 5, etc., that's how many glaciers are feeding this thing. So there's tributaries. Ground moraine, anything that's left behind as it melts. So if you look on I-55, we see a lot of those. Drumlins, we see all this till formed in a teardrop shaped. So I'll show you a picture of that. So we're flowing this direction, and the drop is in the long, drawn out teardrop. So we see the very first abutment, and then it draws out. You can see the teardrops here. Boom, 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 boom. They're all in the same direction. And so if you look close, we see the beginning and then it drags out. So this glacier was going from the top to the bottom. This is called an esker here. And that's where the water was coming out of a glacier. This is a teardrop of a drumlin. Terminal moraine, just like a terminal is in a airport or a bus or a train. A terminal moraine is where the ending point of the moraine is. And so we see a lot of those. And I talked earlier about glacial milk. Glacial milk is this rock flour. Rock flour put into water gives it a really cool white color. You can see all of these different types of glaciers here. Here is that rock of the medial moraine that was from the lateral moraine. And here's that beautiful blue color of the pulverized rock in the water. Stratified drift, right? So again, that comes from water. And where does it go? Well, when we have a glacier that's melting, we have what's called the outwash plain. In other words, that front of the front of the glacier that's washing out on the plain, right? A kettle. Every once in a while, a piece of snow or ice breaks off, and when it does, it just sits there and melts. Well, when you have this big chunk of ice sitting there, it then melts into the dirt and forms a little pond. These are kettles. Here's the inside of a glacial cave, and you can see how the water is flowing. This is forming the item on the right, which is the esker. And an esker is this long gravel deposit that's stratified. So you know you have a river that was there. If we look at the glacial lakes around us, right? So where did we come from? Where did everything else? If you think about the lakes that are out there, um, they're all deposition, right? And so it's not an erosion feature. But if you think about like the Great Lakes was a terminal moraine and lateral moraine blocking all this melting water. And so what ends up happening is we form this body of water called the Great Lakes. And it's got to go somewhere. So where does it go? Out the St. Lawrence River. So again, if we look at the history of the Great Lakes, erosion, deposition, what's going on, melting water, puts it into the lakes. As it does, it finds its way to the northeast, gets to Lake Ontario, and then we get to Niagara Falls. Niagara Falls. So the interesting thing about Niagara Falls is it's only a third of the power that it used to be, because they are diverting 2/3 of the water that was going over Niagara for power. And so the falls aren't as powerful as they used to be, but they're still undercutting. And so they're actually working their way back towards Canada, and moving towards Canada every second of every day. Great Salt Lake's pretty simple. We look at Salt Lake had no way of getting out from where we had our glacial lakes, and so salt gets left behind, and in the process, we see these ancient salt beds. Really cool. So here's the Great Salt Lake, and we'll go ahead and stop there. Uh, You guys have done a great job. I hope everything's going well. Thank you so much. And I hope you guys have a really fantastic day.